Hello and welcome back to Math Class in Session. Continuing with trig derivatives, let's look at y equals tangent x and figure out its derivative. Let's consider y equals sine x over cos x, which we know from trig identities is the same as y equals tangent x. So let's differentiate y equals sine x over cos x. Well, it's a quotient, so we could apply the quotient rule, top thing primed, etc. So y primed equals top thing primed times the bottom thing minus the bottom thing primed times the top thing over the bottom thing squared, which turns out to be cos squared plus sine squared over cos squared. And cos squared plus sine squared, we also know from trig identities, is the number 1. 1 over cos squared. And 1 over cos squared is secant squared, because secant is 1 over cos, and 1 over cos squared is secant squared. And so this is the derivative of y equals tangent x. In summary, d tan x by dx equals secant squared x. Let's take this opportunity to collect up some of the derivatives that we've established this unit. We've got the derivative of tan x with respect to x is secant squared x. And so the derivative of tan of f of x by dx is the secant squared of f of x times f prime of x. We're getting used to this. This is an instance of the chain rule. And we know that the derivative of sine x is cos x. We know the derivative of cos x is negative sine x. And we've learned that the derivative of a to the f of x is equal to a to the f of x times ln a times f prime of x. These are some derivative formulas that we've used several times, and hopefully we're getting used to them. I brought them here as a collection and review. Examples, let's differentiate some expressions using our newfound derivative of tangent. Suppose y equals tangent of an argument, 3x squared minus e to the x. Well, y prime will be secant squared of that same argument. The key here is we don't change the argument. However, we do multiply by the derivative of that argument, 6x minus e to the x. And we like to put that out front so that we make it clear where the argument ends. Going again, let's differentiate this function. So we notice that it's a product of functions of x, because we have x squared times tangent of 2x plus 1. So we'll need a product rule. First thing prime times the second thing plus the second thing prime will be secant squared of that argument times 2 times the first thing. And now, observing the two large terms, we look for common factors. Between the two terms, I see that 2 is a factor of the first term as well as the second term. And I see that x is a factor of the first term as well as a factor of the second term here. So 2 and x can be common factored out as follows, leaving behind tangent of 2x plus 1 plus x secant squared 2x plus 1. And don't be tempted to factor out 2x plus 1. It's not a factor, it's an argument. A third example, y equals e to the x squared minus tan x all cubed. The derivative is fairly simple. We'll take the 3, multiply by the large factor here, all to the 2, and then differentiate the factor as follows. 3 times all of that to the 2 times the derivative in here, which is e to the x squared times 2x minus secant squared x. And really, there's nothing can be done with this. I suppose you could square out this binomial, but it's already factored, so I think we'll leave it as is.